Hello and welcome. Enrichment, integration, indefinite integral, the integral of the square root of 1 minus x over 1 minus the square root of x. Before we attempt it, how many stars is that? In my opinion, this is a 5-star. I actually had this particular integral as a definite integral in one of my books and in one of my papers, and I had the limits 0 to 1. 0 to 1 is slightly, well, actually a lot easier, still a 5-star. But this particular one in indefinite form, I saw it on YouTube by another YouTuber, and I'm going to give some credit to, and in fact I'm going to talk a little bit about YouTube channels if you allow me in the beginning of that, very, very shortly, I promise. In a channel called, by this American guy called Polar Pie. I follow a lot of channels. And this particular guy, if you are a student, I think this is, and you're looking for enrichment material, mainly integration, this is the guy to follow. It's very decent. And there's actually another one that I will personally recommend, and this is an Australian guy. This is more for undergrads, and in particular complex analysis. It's Q-N-cubed. Australian Asian guy. He does a lot of the stuff I do for undergrads, a lot of things with complex integration and summations and things like that. There's of course a lot of other YouTube channels, but what I would personally call celebrity YouTubers. I personally will not recommend them if you're a student. I think most of them are a total and utter waste of time, and there's 3 signs to watch for when you're picking to subscribe into this YouTube channels. Avoid channels that have 3 things, all 3, or many of these. Somebody very young. I'm not saying if you're young you're not good, not necessarily, but in generally somebody who's young, somebody who's pestering you to subscribe and like. I've done in excess of 80 videos now so far, guys. I never asked anybody to subscribe or like my videos, okay? I'm not trying to make money or become a celebrity. And what is the third reason, the third thing that you should watch for? Channels that have merchandise, okay? These are all celebrity YouTubers. The reason the channel is there is to make money and just gratify their existence. Just a total waste of time for the typical student. I'm not saying they're a complete waste, but it's not really going to get a lot out of this subscribe to those channels. Anyway, this integral came from Polar Pie. He doesn't show this particular method, and I did put a little comment and I said I'm going to do this on my channel and I'm going to show my method, which I believe is quite clinical and quite clever. It's not the only way you can do this particular integral. So I'm going to show you now how to approach something like that. If you want to have a go, pause and come back if you're looking for alternatives. First of all, I tried on this particular one to, let me just turn the mic. I hope there's good sound. I tried trigonometric substitutions on this one before I'm going to show you what I've eventually done. That didn't work quite well. Perhaps I didn't give them enough try. I didn't pursue far enough, but because I thought there's a better way of dealing with this, I saw a better way and I done it that way, and it worked very, very nicely. So this is now my approach. Okay, the first thing is a manipulation. The manipulation that I'm going to do is I'm going to multiply top and bottom by the third conjugate of the denominator, and you will see in a few steps why. So 1 plus the square root of x, and on the denominator 1 minus the square root of x, 1 plus the square root of x dx. What happens now on this particular one? The denominator, of course, the difference of squares, 1 minus x, and on the top I'm going to have 1 minus x square rooted times 1 plus the square root of x. At first glance it looks that I'm doing stupid things, but it's not. If you watch, this of course cancels. So I've got to the half, I've got to the 1, so that becomes now 1 minus x on the denominator, 1 plus the square root of x on the numerator. Okay, so far so good. I claim that this particular line is better than this because it consists of 1 item compared to that was 2. What can I do next? Okay, you can again try substitutions, maybe trigonometric. Perhaps you can say x is the sine squared or something like that. I don't know. I didn't try it because something else was tempting me to do a different thing. What's the different thing? I'm going to use a substitution. U is the square root of 1 minus x. With substitutions like this, I'm going to square it. Then I'm going to write it as x is 1 minus u squared. And then my dx is going to be minus 2u du. So far, so good. I don't know if I need more stuff. Let me just leave it open and let's see what happens. Looking at this line, my denominator, first of all, is simply u by my substitution. And the numerator is going to become 1 plus the square root of x. The square root of x is that. 1 minus u squared, square rooted, minus 2u du. Anybody who's experienced now in integration will just look at that and say, I'm going to give it now to somebody to finish it off, because that is actually not hard at all. Should be obvious. Cancel the u's. And this minus 2, I don't know whether I should just write it inside or pull it outside the integral. Let's leave it inside. Minus 2 square root of 1 minus u squared du. What do I do there? That's the trigonometric substitutions. One of the standard forms. In fact, in many American books, these are, or American formula books for exams, this form, this integral, is given so you can actually quote it without doing anything. It will tell you what that is. I don't remember what that is. I have to, because I've been educated in the UK. It was never given to us, and therefore I always do it from first principles. So let's continue with that. First of all, this will integrate with respect to u to minus 2u. So we got rid of that, and I'm going to split the integral into minus. Let's leave the 2 inside. Actually, no. Let's leave it on the outside. Minus 2. That's this bit here, and now I have the square root of 1 minus u squared du. Okay, I don't think I need anything more from here, but I need another substitution. The substitution, of course, is u is equal to either sine theta or cos theta. And for those who understand a little bit better these kind of things, the actual substitution is not that. It's a one-to-one function, and it's in fact theta is the arc sine of u. But we use this particular one because it's easier to do the algebra. So my du will be cos theta d theta. I don't think I need anything else, but if I do, I'll come back to it. Okay, that's the minus. I forgot that I've already integrated this. I'm not putting my substitution back in until I finish with that, and I'm going to put my things together at the end. Minus 2. I hope I'm not in the way. I'm going to try to turn sideways a little bit so you can see behind me. So that's the minus 2. The substitution now is going to be, of course, square root of 1 minus sine squared of theta. And my du is, of course, cos theta d theta. Cos theta d theta. Let's close that and let's continue. Equal to minus 2u minus 2. This, of course, is cos squared. There's a cos from there, positive square root, of course, times a cos is a cos squared d theta. This is a standard trigonometric integral that, of course, we are expected to know how to integrate. By the way, the stuff required on this particular integral is just enrichment, standard maths. There's no further maths involved. In other words, specialized techniques like having arc sines or things like that. So probably better, I don't want to rewrite it again. Let's leave it because I wrote it like that. In order to integrate that, I need the double angle written in one of his rearrangements. So that is going to be now the cos squared theta is a half plus a half cos of 2 theta. It's a standard identity. If we are in enrichment, so you ought to understand where it's coming from and how to integrate things that look like that. And of course, now we can say that this in fact is equal to minus 2u let's leave the -2 and finish off this integration. I'm going to use a bracket because of the -2. This is going to be a half theta, because the integration with respect to theta, and this is going to be 1/4 sine of 2 theta, close brackets, plus of course the final constant. And now all I need to do is to reverse all my substitutions, because don't forget I've done 2 substitutions along the way. So I need to go the thetas back into u's, and then eventually once I have u's everywhere, go back into x. So first of all, let's multiply this bracket. -2u minus a theta, loads of minus on this one, minus a theta, minus a half sine of 2 theta. I'm going to move out of the way so we can check it. -2u minus a theta minus half sine 2 theta, and I need to rewrite it in order to work my substitution back. So not changing anything yet. All I'm going to do is write this as 2 sine theta cos theta, and that 2 will cancel the half. So sine theta cos theta plus a constant. That surely has to be easy enough now to go back. The thetas first. Theta is of course the arcsine of u. So that's going to be minus the arcsine of u. The sine of theta is u. So that is a minus u. What is the cos? Well, the cos, because we have arcsine, so it's a 1-to-1, I should really write it here. The cos of theta is the positive square root of 1 minus sine squared theta, is not plus or minus, and therefore the cos of theta will be the square root of 1 minus u squared. So that is going to be square root of 1 minus u squared plus c. And I've got to go one step back from there, because don't forget that was in x, and I think that's a trivial step, and I will give a scope to write the answer in a couple of ways, I would imagine. U is just the square root of 1 minus x, 1 minus x, minus the arcsine of the square root of 1 minus x, and then we're going to have minus u is the square root of 1 minus x. And what is now 1 minus u squared? Luckily I have it up here. The 1 minus u squared is here. The square root of that is in fact the square root of x. So we can write that now perhaps as, we can put these 2 square roots together. That's one way of doing this. Let me just show you a couple of ways we can write this. You can actually, there's lots of minuses first of all. -2 square root of 1 minus x. Let me move that together, and at the same time let me just put the 2 square roots together, minus the square root of x minus x squared. So that's one way. So that's this lump here, minus the arcsine of the square root of 1 minus x plus c. And another way is we can perhaps factorize out of those 2 terms. So that's an alternative. I'm going to write it up here, not from this line, from this line. Factorize a negative square root of 1 minus x out of that and out of that, and that will leave me inside the bracket +2 because I pulled the minus, plus because I pulled the minus the square root of x. So we can have it like that. So that's these 2 terms together, and of course the arcsine, I can't really do anything with it, plus c. So either of those 2 answers is what I make. This is not the only way of doing this. There's several ways you can have equivalent answers. You can end up with arctans. It's going to be, the arctans are absolutely ugly if you go for that. I'll be interested to see if people have come up with different answers for this particular integral. This was my method, and I hope you enjoyed it. And this is the challenge that I would personally recommend for maths. This is for people that are in year 13. in, further maths in particular, and this is for people that are undergrads, for complex analysis mainly. This is the kind of channels that I would personally recommend. I hope you enjoyed it. I'll see you very soon. Who's laughing now?